Some aspects of complexity. Complex systems are highly sensitive to small changes. This is why they're non-causal. Yeah, it's interesting, it's very easy to explain this in a Hindu or a Taoist environment, because those philosophies never got rid of the concept of a non-causal system. Some things just are. Yeah, next time they'll be different. But we removed that from Western philosophy in the 17th century, yeah, to our considerable loss. But basically, what you're dealing with is a system where one small change today may produce no system effect whatsoever, but the same small change tomorrow may generate a massive system change. You can see this if you just want a simple example. Look at the press. You know, one day they pick something up, it magnifies. The next day they ignore something worse. In complex adaptive systems, you can't predict in advance what will cause the surge, which is why weak signal detection, fast monitoring is key. Proximity is critical. I mean, anybody got teenage children? Okay, well, the thing you most worry about is when they hit puberty. And the thing you most worry about is who their friends are. Because who they interact with has the most influence over them. And for those of you with teenagers, I'll give you a free gift. This is an interrogation technique. You need it with children. When they come back at 3 o'clock in the morning, you don't know whether to kill them or hug them. And they have some wonderful story involving mobile phone reception and how they really did the sensible thing, and you're pretty sure they're lying through their teeth. Get them to tell the story backwards. It's almost impossible for a human to lie backwards consistently. In fact, in the intelligence service, they spend weeks training people to do this on alibis. I've used it with students on essay excuses, and it's actually very effective. Right? But it's extremely effective with students, but that's a side one. Meaning emerges through interaction. There's a huge density behind this. But fundamentally, one of the things we're starting to talk about now is the concept of meaning has become problematic, just like knowledge was problematic about 20 or 30 years ago. From a complex system, meaning emerges as a result of interactions. It's not pre-given. This doesn't mean we're into relativism, but it means we're into an evolutionary approach. Different things mean different things at different times. And then there's two key phrases. Hindsight doesn't lead to foresight. But the big shift is a shift from fail-safe design approaches to safe-to-fail experimental approaches. The minute you realize the system is complex, you can't design the right solution. What you have to do is to move into small, safe-to-fail experiments, each of which needs to pass a test for coherence. There's a rigor to complexity management, which actually I would argue is more rigorous than order systems management. But you shift from fail-safe to safe-to-fail, which actually radically reduces the cost of intervention. I can talk later, if you want, about some of the work we're doing on urban design. Yeah, because actually that's one of the issues where you need to create a co-evolutionary process between people's needs and engineering capability. To take something from the IT industry where I grew up, there's an adage, users don't know what they want until they get it, and then they want something different. The reason is that they don't know what the technology can do until you give them the technology, and then they start to do things with it you didn't expect. So good design takes a safe-to-fail approach anyway, but now we're starting to get some of the science behind it to amplify that. 3 basic rules or heuristics to managing a complex system. One is distributed cognition. Now this is a phrase of increasing importance. It's sometimes known as wisdom of crowds, but that's a very bad phrase. Crowds are generally herds and stupid. Right? We'll come back to wisdom of crowds in a minute. The proper phrase for it is distributed cognition. What you want is large human sensor networks as part of your cognitive process. This is not the same thing as delegation. And a lot of the ideologues like Sengi and Seddon just think it's all about delegating to people. Actually, it isn't. In a complex adaptive system, you may centralize control for good reason. It's what you control that matters. There's nothing wrong with command and control in the right context. It's a great mistake to try and denigrate that. And I'm speaking as a former Welsh Catholic Marxist, all right, so I'm allowed to say this with impunity. Working with the US government, but never mind, that's another story. We need to work with finely grained objects. Small organizational units can be combined and recombined very quickly. Basic law, the law of 5, 15, and 150. Now these are approximate numbers. 5 is Miller's number, the human short-term memory 7 plus or minus 2. 15 is a natural limit on how many people can simultaneously trust each other. It's actually a learned behaviour. It's proportional to the average size of the extended family in the society in which you grew up. Because it's an habituated pattern learned when the brain is very plastic. And 150, which is linked to the neocortex, is a number of identities you can maintain in your mind at any one time. Those are natural limits on work groups. Yet the behaviour changes as work groups go through those barriers. There may be plus or minus 2 in each case, but they change. Small groups can be assembled and reassembled in different forms very quickly. Large bureaucratic structures can't actually break apart and be put back together again, except at enormous cost. If you're dealing with a dynamic system, you need small units. The work we do on research, which I'm going to talk about at the end, works with micro-narratives. The narratives at the queue, at the checkout queue, the water cooler, the school gate. Those are the narratives which determine how people will behave, not their responses to questionnaires and surveys. Yet we're dealing with micro-narratives, not grand narratives. So small, granular units are key. Currently doing work to bring the military concept of a crew sideways into industry. In a crew, the crews are never more than about 8 or 9 people, and people are trained in role and role expectation. So a crew can be assembled from people who don't know each other, who've never worked before, but it works. So rather than tiger teams and matrix-based structures, what you do is people come in, they're assessed and trained into role, and the entry into the role is ritualized. That's very important. Ritual is key to triggering different human response patterns, which actually allows you to assemble and reassemble across silo crews very quickly. You see the sort of small granularity and the application of some basic science. And then finally, disintermediation. This will make much more sense right at the end. Disintermediation means putting decision makers directly in contact with the raw data. Now, a seminal contract for me some time ago is I worked with the board of Lend-Lease. Anybody remember Lend-Lease? Australian engineering company, built blue water, pioneering guys. The way they managed projects is they had 3 people who went around the world and did project reviews, and nobody ever got out of a project review without being beaten up. But actually, they never told them what to do. They connected them with somebody else. And it was almost like a ritual. The guys have arrived, they're going to take us apart, but then they're going to tell us not what to do, but connect us with other people who may be able to help us. And every now and then they get in a helicopter and they fly over the site and they work it out for themselves. Because they knew they couldn't rely on multiple reporting levels. That would destroy weak signal detection and opportunity spotting. So disintermediation is putting the primary decision makers in direct contact with raw data. Right, so these are 3 basic heuristics or rules as to how you manage a complex system. You guys want more on this? That's a Harvard article. I'm sort of proud of this. It's an awful article because it has to go through 8 levels of editorship to get in the Harvard Business Review. You do it for marketing purposes, right? If it's a cover article in the Harvard Business Review, however, which it was, then it's respectable. Yeah, and I'm pleased that also won the Academy of Management Award that year, so we were respectable in 2 communities. But that's there, you can see it. So distributed cognition. The 2 classic cases on this are farmers guessing the weight of a cow at a fair. Anybody heard this one? So all the farmers guess the weight of the cow, and the average of the guesses is the weight of the cow. The other classic case is an American submarine grounded. They don't sink. I was corrected on that by an admiral in Norfolk. He pointed out submarines are meant to sink, which is a bit embarrassing, but it's life. When they go down and they won't come up again, they ground. They had a week before they ran out of oxygen. So they got groups of experts, fishermen, ocean current specialists, working completely independently of each other, each to give an estimate of where the position was. Then they averaged the position, and they were within 6 meters of the submarine. The key principle here, though, which not everybody gets, is that nobody must be aware of the guesses of the other people. Because the minute somebody puts a guess up, everybody else brackets it. The other thing is the people who make the decisions have deep, tacit knowledge. Now, just to give you something else from cognitive science, we know it takes the brain 3 to 5 years to physically readjust itself around a new knowledge base. we now know the cognitive science reasons of why apprenticeships are key. You can't acquire knowledge by reading it on a database. Yeah, knowledge is actually also extended into the muscular system, the hormonal system, and interestingly for engineers, scent is more important than you think. Yeah, scent actually works at a subconscious level, and experienced engineers will actually discover a lot of fault finding in that way. Right? And that takes time to acquire and gain. And so we then got some of the science to justify some of the things. Experienced people, well, no profession worth its salt has ever got rid of apprenticeships because they know how critical it is to the way it works. Now, I have a niece at Bristol University who's a medical student, and we almost got expelled because she and her friends hooked themselves up to the dialysis machines every Sunday morning to clear out the alcohol from the day before. And I think the disciplinary tribunal reckoned, okay, they had sinned, but they'd sinned in a way which proved they'd understood medical theory, so they were allowed to continue. But you talk with doctors, they will all tell you that type of story. I've been doing work lately to get the stories from doctors of the first death they caused. And every doctor can tell you the story of the first person they killed. It's almost like a transitionary moment, a point where you start to realize things are serious. Right? It takes time to acquire human knowledge. So you need the tacit knowledge. We're now using this for mass consultation. We're starting to build battlefield systems now where the whole of the army can be engaged in helping the general make a decision without the general having to declare the decision. Yeah, modern technology allows us to use this more extensively.